Today we're going to focus on solving for variables. Well, over the course of this chapter, we've essentially studied practicing using operations in algebra. We've used variables to represent quantities. We had a section where we wrote expressions to express situations, and we've even simplified and evaluated expressions. So here in lesson 2-5, we're going to be solving for variables. Well, in doing so, we'll continue to use the inverse operations and solve equations containing variables. So we are going to kind of just do a compilation of all the skills that we've acquired over the chapter and add a couple more vocabulary terms along the way. So our first objective is to solve a formula for a given variable. So we know variables are letters. So letters such as X, we've seen Y, Z, etc. So any letter is a variable. Then we are going to solve an equation and two or more variables for one of the variables. So again, that objective is to solve an equation and two or more variables, with two or more variables. With two or more variables for one of the variables. So what that essentially kind of tells us is that we may have multiple variables in the equation, and we are going to be solving for that information. All right, so let's look at the vocabulary terms that we have here. And these should be all a review. So the first term that we're looking at is equation. Well, and you think about looking at equation, you think about the root piece of it, which is equation, which kind of looks like equal. So equations usually are going to equal. So you'll have perhaps a number on one side plus 5 equals 8. So it's an equation because you have two different sides of the equal sign. Expressions, we said, are just one side. So 3 plus 5 is 8. And then we have 8 on this side. So as you can see, it equals. So your next term is a literal equation. So you think about the word literal, and I know for me, it's like literally exactly what it says. So if it says stop, it's a literal term, stop. So in the essence of mathematics, a literal means of letters. So in this case, we know that letters are going to be involved. So the word literal means of letters. So literal, it will be different from the equation we have here because this equation just has numbers. Whereas a literal equation is going to have letters as well. So perhaps something similar to maybe 3A. That way it includes letters plus 5A equals 8A. So it has alphabet as well. So literal is going to mean of letters. So we know that letters are going to be a part of what a literal equation is. Then we look at the word identity. Well, again, identity. Identity, so if I said to give what's your identity? So that's going to be an example of just exactly, who it is. So it's an exact answer. So that's what identity means. And then we have the word percent. So percent, if you look at the base part of that, you're looking at per. Per means each. Now, anyone who knows a percent means percents are usually out of 100. So we're looking at percents. So in the cent part, is this cent, which means this is what means each, and this is out of 100. So, and those are the terms that we're kind of looking at right now. All right, so let's go ahead and just dive right on in. So if you look at the handout that was given to you, which is Reteach 2-5, that lesson, or we're going to look at the reading strategies. So just want to look at a concept map and kind of talk about that a little bit. So looking at the concept map, it gives us the definition. So literal equations are equations with two or more variables. Okay, with two or more variables. All right, so if we're going to, then let's go ahead and modify this right here. So two or more variables. All right, so we got 3a plus 5b. And let's just leave that blank there. All right, so two or more variables. So it's an equation with two or more variables. All right, next we have, as we're looking at this, it says an example. So an example would be distance equals rate times time. So we know the D means distant. So how far are you going to go? Rate is how fast you're going to go. And time means how much time is it going to take you. So let me just kind of write that again. D equals distance. Rate means how fast. Or the speed. And then time means how long, what length of time it took you. All right. So we have D equals RT. Next, we have the formula for area. So A is for your area, and then it's equal 1/2 times the base and the height, which is typically what, a triangle. And then the next one we have M plus N equals 3P. So based on our definition, literal equations are equations with two or more variables. So, and this one just definitely tells you that. So M is a variable, N is a variable, and P is a variable. So remember we said variables are letters. All right, so let's go ahead and move on. It says facts. Formulas are literal equations. So formulas are literal equations. Then we go over in literal equations are solved the same way as equations. So literal equations are solved the same way as equations by using the inverse operation. Now, remember we said the inverse operation means opposite. So if it's addition, that would mean subtraction. If it's multiplication, that would mean division, and vice versa, the inverse operation. So then it has us to look at some non-examples. All right, so non-examples. Non means not, right? So these are not examples of a literal equation, kind of like inverse operation. All right, so we said literal equations have two or more variables. So the reason that this would not be it, because it only has one variable. All right, now in our next one, it says 10 equals 1/3 in parentheses y minus 6. Once again, only one variable. And our third example, it says n plus 5 minus 2n minus 14. Once again, only one variable. It's the same variable. And we said a literal equation are equations with two or more variables. All right, give yourself, looking at number 1, it says give your own examples for literal equations. So let's see, another formula could be for a literal equation. I got one. L 2L plus 2W. That could be a formula. And that is for what? Uh, that would be the perimeter. All right, next it says y is n plus 5 minus, minus 2n minus 14 given as a non-example. Well, one reason would be is it needs to be an equation. Oh, you know what? I'm sorry. That is the equation. All right. One example would be that it's only one variable. Number 3 is an equation with 4 different variables, a literal equation. Why? Well, let's look at the definition. The definition says 2 or more variables. So it says is an equation with 4 different variables a literal equation? That would be yes. And that would be yes because the example indicates more than 2 equations. All right. Next, it says describe how to solve D equals R times T. Well, we know D equals R times T because when you have 2 letters or a letter and a number, it means multiplication. So to solve for T, that would mean we would need to divide by R here, and then that means we would need to divide by R here. So it will be T equals D R. So, and you can finish the last 2 examples. If you have any questions, please feel free to give me a call. Again, this is lesson 2.